Buy war bonds, everybody. Hi.
Hi.
I'm Skip Alzheimer, and you are?
Katja Seltman.
And welcome to the AV Geeks Lunchtime Streaming Show. I'm going to mute this because it's not muted. All right. Anyways, you've been on the show before.
Yeah, I have several times. Well, I think it was like maybe last year or so. Let's talk insects.
Yeah, talk about insects. And you're in town because tonight there's going to be
a live show.
A live performance.
And video mixing between AV Geeks and Irene Moon.
Yes, Irene Moon versus Erwin Moon. AV Geeks, of course, loves Erwin Moon from the Moody Institute of Science. So there's going to be a blend of it.
I'm an entomologist. I study insects. So we're going to talk about moths during the show.
Yes.
And sing songs about moths. And
this will be 6 o'clock Eastern Standard Time at the same places. So YouTube, Facebook, kind of, Twitch, etc. So join us for that. You can also go to the AV Geeks page and see it. So today, since you're an entomologist, I pulled a bunch of films about insects, including some that we haven't seen before. Killers of the Insect World we saw before, but not without your insight. Like, was there any takeaways from this? Because that film was probably made in the 20s.
Yeah, that was a really cool film. The first thing I have to point out, though, is that not all of the organisms in the film were actually insects. I mean, probably people already know that, but the first part where it was the wasp and the praying mantis and the cricket, those were all insects. They have 3 pairs of legs, but everything after that wasn't an insect.
But would you say that those are things that kill insects?
They would eat insects.
So yes. That they are technically killers
of
the insect world,
yes.
Versus
this is true.
Being of the insect world and they kill.
The thing about the film, though, is like I would bet money that they threw that wasp into that.
Oh yeah,
that spider web.
All of this was definitely
small aquarium. Yeah. Wasp spider web.
Oh yeah.
Yeah.
Oh yeah. They weren't out in nature filming this stuff. There's no way.
The coolest part, though, was the demonstrating the Sphesid wasp. So that really cool large black wasp that was when it stung the cricket in the back of the head, and they do parasitize them and drag them into layers, and they're alive, and then lay their eggs on them. But it was really neat that they showed that the actual act of where they sting, because they sting right in the nerve cord.
So this is kind of a precursor to the zombie. Some of the zombies of the insect world, where they kind of they go in and take over, and then use it to spread their species. All right, so I've got a film set up on the scanner behind me, and it's beat up, so it's been shown a lot, but it's called Insect Collecting, I think, because the title's all torn up. But I'm going to have to put my finger on it to keep it running. So let's go ahead and watch Insect Collecting, and then you said you had a lot to say about insects.
I collect a lot of insects. Yeah.
All right. Enjoy.
Animal kingdoms. The study of these little is a science and necessary insects than all other forms of life combined. So the valuable thing about insect collecting is that everyone, regardless of where he lives, can find insects living nearby. But before a specimen can become part of a collection, it must first be caught. And that's what our story is about. The necessary steps of finding and collecting these interesting yet often unnoticed members of the animal kingdom. The collector must sometimes go to where the insects are. For example, flowers attract insects that feed on nectar. So that's where you go to secure this particular insect. One of the most widely used methods of collecting insects that fly is with a net. Once the insect is captured, it can easily be confined in a container and later prepared for mounting. Some insects come out only at night. A way to secure many of these is to attract the animal to the collector. All that's needed is an attracting light and a light background, such as a sheet. Nocturnal insects are accustomed to very little light, and so they're attracted into the bright area that stands out so well in their world of darkness. Light collecting is one of the finest. Many insects are difficult to find, even in the daytime. So well do they resemble the plant upon which they live that you can look right at them and not see them at all. A good way to collect these protected little animals is by the beating method. A sheet is placed beneath the plant upon which the insects live. The contrasting sheet is not the same color nor form as the insects that reside above. When the sheet is in place, the limbs of the food plant are beaten with a stick. Dozens, often hundreds of insects may be dislodged from their protective perches onto the sheet below. Each insect now stands out clearly against this unfamiliar background and can easily be caught. Fallen plant particles are also collected in bags. Later examination of this material may reveal smaller creatures, or it may reveal the eggs of a generation of insects yet to come. Eggs soon hatch into tiny larvae, which can be added in larval form to a collection or raised into adults. But more about raising insects a little later. While some insects feed and live upon a growing plant, others feed and live among the fallen and decaying material from the same plant. Many of these insects are so small that they can neither be seen nor collected in the field. So the decaying material in which the insects reside is collected and taken home for separating by the Berlese funnel method. A funnel is suspended over the workbench. Some alcohol is put in a small bottle and placed beneath the funnel. A fine mesh screen to prevent larger particles from falling through is placed in the top of the funnel. The material that was collected in the field is placed in the screen. A bright light is placed over the top of the material. Any tiny insects contained in the material move downward to escape the light. Within a few hours, many of them crawl through the fine openings in the screen and drop into the alcohol below, being quickly killed and preserved at the same time. A microscope must be used to observe these minute animals. Magnified many times, you can see that these tiny animals are true insects and differ only in size from their more easily observed counterparts. Home for many insects is under the dead and crumbling bark of the host plant. One may find the adult insects, but may just as often find them in one of the immature stages of life, such as the growing stage. This is called the larval stage of life. Cleverly hidden from view nearby, you may find the restive cocoons of the same animal. Now the insect is in the pupal stage of life. The cocoons may be collected, and later, an adult insect will emerge. Some cocoons will probably be occupied by parasites, which have eaten the original inhabitant. In this case, you'll add not a moth to your collection, but a small parasitic wasp. The cocoons of different insects can sometimes be found beneath the same bark. This particular one develops into another colorful adult moth. Some insects are found within the wood itself. This grub-like larva develops into an interesting adult beetle.
A splicing tape that's sticking, so give me a sec. Apologize for that. Very frustrating. So basically there's bad sprockets on there, and so somebody used sprocket tape to fix it.
That's too bad, because that was an amazing film.
Yeah, I'll see if I can get it back up later.
You know, we still do that. We collect insects in the exact same way that film.
Using the Burr-Lazy method?
The Burr-Lazy, yeah. Burr-Lazy funnel method. Well, the insects, they don't like the heat, so they try to escape from the heat, and they end up in a pool of alcohol. So, yeah. And
when you saw them pouring the alcohol, what did you say?
I said 1 shot for the entomologist and 1 shot for the insects.
Nice. All right. Well, this film is Insects in a Garden.
Okay.
Enjoy.
Almost everywhere on Earth, even in a garden like this, we can find many different kinds of plants and animals. Here, we can observe a variety of small animals. Some of them are insects. On a single rosebush, we may find several kinds of insects, such as ants, a green lacewing, a ladybird beetle, and aphids. Aphids are also called plant lice. An aphid is about as large as the head of a pin. These tiny insects get their food by sucking juices from the stems and leaves of plants. But sometimes aphids become food for other insects. Even though many aphids are destroyed in this way, some survive, because aphids reproduce in large numbers. Here, a young aphid is being born. As the tiny aphid leaves its mother, its skin hardens. This hardened outer covering becomes the aphid's skeleton. What other animals have an outer skeleton? Reproduction, such as that of the aphid, is not common among insects. Most insects develop from eggs outside the mother's body. This green lacewing, for example, lays its eggs on the underside of a leaf. To lay its eggs, the lacewing spins a fine thread with a liquid from its body. Then it attaches an egg to the thread. The first stage of the lacewing's development takes place inside the egg. After several days, the egg hatches and a juvenile form, the larva, emerges. How closely does this larva resemble an adult lacewing? Let us watch the lacewing larva as it develops into an adult insect. The larva has specially adapted mouth parts and is able to feed itself as soon as it hatches. How tiny the lacewing larva is compared to an aphid. Yet the larva is able to attack the aphid and feed on it. Although the aphid is much larger in size, it cannot defend itself. The lacewing larva eats and grows rapidly. Soon it has grown many times larger than an aphid. When the larva is fully grown, it is ready to begin a new stage of development. Now the larva attaches itself to a leaf and spins a soft protective covering called a cocoon. Inside the cocoon, the larva will change into a pupa. During this pupal stage, the larva will change into an adult insect. This process of change is called metamorphosis. The word metamorphosis means change. Nearly all insects undergo metamorphosis. If this is an adult lacewing, where are its wings? If we look closely, we can see the wings expand. As the lacewing moves, it pumps body fluid through the veins in its wings, helping to expand the wings to their full size. Soon, the adult lacewing is ready for its first meal of aphids. Nearby, another insect, a ladybird beetle, is laying its eggs. The ladybird beetle also goes through a metamorphosis. Can you recognize the different stages? The ladybird larva is now ready to become a pupa. But instead of spinning a cocoon, the larva curls into a ball, and gradually its outer skin hardens to form a pupal case. This is different from the cocoon spun by the lacewing, but it serves the same function, to protect the developing insect. Later, the adult ladybird beetle emerges from its pupal case. Gradually, the color of its body will change. And for its first meal, what does the ladybird beetle eat? At first, it might seem that aphids serve only as food for other insects. But watch closely, and you will discover that aphids play another role in this community. As they suck plant juices, aphids give off a fluid that serves as food for ants. In exchange for this food, the ants protect aphids from other insects that might be harmful, such as the ladybird beetle. In this way, ants and aphids help each other. Think of other animals that help each other. We have looked closely at a few insects in this tiny community on a rosebush and have found that some insects are plant eaters. Others feed on the plant-eating insects. Some insects are helpful to each other. Some insects, like the aphid, bear young that resemble the parent. But most insects pass through a series of changes called metamorphosis. There are more kinds of insects on Earth than all other kinds of animals. No matter where you live, you can discover many insects and observe their role in the world of living things.
So you pointed out at the end there was a native bee.
Right. There was a bee that is not a honeybee.
Right. And so what that means is honeybees are not native.
Not to the United States. But I mean, your people who are watching could be watching from all over the world.
That's true. That's true. So because one of the things I asked you for this morning, I was like, what would you like to see? And you were like, I'd like to see some bees, but not honeybees. And
right.
I was like, I don't know if I have footage of native bees. Most of the educational films talk about bees, and they talk specifically about honeybees.
Well, honeybees are really important. They pollinate a lot of our crops, and they provide honey, and wax used to be even more important than it is now. But people are getting more and more interested in insect declines and declines of our pollinators, and maybe even declines of honeybees too. And our native bees are great pollinators too. So there's like 20,000 species of bee on the planet. Why care so much about just the honeybee?
Because it makes delicious honey.
It does do that. I also wanted to talk about aphids a little more. Aphids, that someone mentioned on the chat that it reminded them of Cronenberg films. I have no idea. So aphids are also parthenogenetic, which if you think about the movie The Brood.
Right.
Yeah.
Right. Oh yeah, the budding of the...
Exactly.
Yeah.
Yeah. So aphids don't have to mate to reproduce. They're clones. So,
that's interesting. All right.
Yeah, so it might have been... That film potentially could have been the inspiration.
And so what insects use aphids as a food source? Like, of what they produce, that aphid milk?
Well, ants definitely do.
Ants do?
Lots of different kinds of ants.
All right.
Use we call it honeydew. But other Hymenoptera do too. Hymenoptera being the order of insects that ants belong to. Ants are the only ones that really farm it. But if you look carefully, you'll see if there's an aphid colony, there's other ants, there's other little wasps and stuff that will come in and do the same thing.
Interesting. And so when you talk about ants farming aphids, how do they do that? Like do they have something in an anthill that actually is dedicated, like stables?
No. They farm in the sense is like the ants find some aphids, which is not that hard because aphids are all over the place, and then they protect them, and the aphids provide this lovely secretion for the ants that encourages them to hang out.
And how do they milk them?
I think they tickle them. They give them a nice little tickle, and then
they barf.
But out of the other end.
The other end, so they poop.
Yeah.
Or they express.
They express, yeah. So ants, aphids have, because they suck plant juices, right? So they're just basically on liquid diets. So they're sucking plant juices all the time, which is not that healthy to be on a liquid diet because you end up with all this water you have to get rid of.
Right.
So aphids do this anyway. They don't do it just for the ants. But they have a kind of a digestive system that's recircular so that more water can be sucked into the excretory system, so the food gets harder and harder, and so it's more nutrition and less water. And so they have to expel that water somehow. And it just so happens to be a little bit sweet. And so because it's sweet, the ants like sugar.
All right. Well, that's happy lunch, everybody.
But, I've tasted it.
Uh-huh.
It can be sweet.
Oh, yeah?
Yeah. It's sugar. So if we ever run out of honeybees, aphids maybe are our next goal.
Yeah. Okay. Yeah, maybe that's a great project there. But they don't pollinate, so there's that side of it, doesn't it?
No, they don't. They don't pollinate.
All right.
They don't, and they're destructive because they carry diseases. They're basically walking hypodermic needles.
That's a great description. All right, so speaking of insect foods, this is about insect foods, and so we'll probably hear about aphids again and maybe some other things. Maybe your sweater. Enjoy.
Of the animal kingdom. Over 1 million known species exist today. There are more kinds of insects than all other forms of animal life combined. A large part of every insect's life is spent in eating, and this is why they are so important to man. Their silent and oftentimes unnoticed search for food is important to everyone. For all living things, plants and animals alike, provide food for insects. Some insects can eat their own weight in food in only 2 hours. A grasshopper is such an insect. Multiply this appetite countless millions of times, concentrate it all in a farm area, and the grasshopper becomes a competitor with man for his food supply. In this film, we're going to see a few examples of both harmful and beneficial insects. We'll see what and how they eat. The katydid is an insect that eats different parts of many plants. It feeds at night and is seldom seen. Its color and form make it appear deceptively like the plants upon which it feeds. This insect eats often and fast, and normally it eats almost any type of plant. Its mouth parts are well adapted to its food-getting requirements. Fortunately for us, this insect is seldom a problem, for in all stages of life, it's controlled by other insects, birds, and other small animals. Here's an insect that is a problem. This is the larval, or immature stage, of a beetle. This insect feeds only on grain, and feeds mostly during this larval stage. Modern man stores his grain, huge piles of it, and so a situation has been created in which these beetles become pests. They spend their entire lives in the stored grain, burrowing down and eating this basic food of man. When the larvae are full grown, they enter the pupal stage. Now they're alive but dormant. Notice how much they look like the grain in this most defenseless period of life. Eventually, adult beetles emerge from the pupae. They feed and reproduce and will continue to exist here for many generations until the food supply is exhausted. The Polyphemus moth larva is an interesting insect feeder. This colorful caterpillar is a determined diner. Its diet is restricted to the leaves of certain trees. The Polyphemus feeds only in this, the larval stage of life. The feeding period is a short one, perhaps no more than 60 days. So the caterpillar must eat now, continuously and without delay. Like so many insects, this one's body is especially adapted for feeding in a particular habitat. The Polyphemus best supports its heavy weight by hanging upside down by its efficient little suction-like feet. Notice, too, how this slow-moving insect is protected by its resemblance to its surroundings. Even the side markings resemble the veins in the leaves upon which it feeds. When the Polyphemus caterpillar is through feeding, never to eat again, it spins a cocoon, using this previously eaten food as stored energy to make silk. This it does with the same determination it displayed earlier in life. The finished cocoon is a hard, leathery sac. It affords good protection to the developing adult within. A window cut in this cocoon exposes the dormant pupal insect, which no longer resembles the feeding larva. It is slowly undergoing complex chemical changes that will eventually produce this beautiful moth. The adult never feeds. In fact, the adult, the pupa, the cocoon, the complex changes in structure, everything is a result of the feeding this insect did for a short period in its life. This imposter looks like something that it isn't. It resembles a wasp, but it's actually a moth. It's called a wasp moth. The adult lays her eggs in the crevice of a tree stem. The eggs hatch, and the larvae feed by boring within the living tree. The larvae pupate inside the tree stem, emerging as adults. All that remain are the empty pupal skins. The tree is either weakened or killed as a result of providing food for this destructive moth. Numerous holes in this piece of dead wood show that it has provided food for other boring insects. These insects are found mostly in forest areas, in the branches and trunks of fallen trees. The insects are termites, a group that eats only dead wood. The termite has a bad reputation because it often eats the wood in people's houses. But these termites are engaged in useful work, helping to decompose a dead tree. Were it not for termites and other insects that feed upon dead wood, the world would be cluttered with fallen trees. And while the termite eats dead plant material, dead animal material is eaten by other insects. These are the larvae of a carpet beetle. They feed exclusively on dead insects and other forms of animal life. They're often pests because they eat the dead animal material with which people make their rugs and clothing. But here they are doing useful work. Within a few weeks, this dead butterfly is reduced to dust, and the dust will enrich the soil and so help support the plant and animal life yet to come. The clothes moth has a bad and well-deserved reputation. The adult insect, however, is not destructive. It's in the larval stage when damage is done. Clothes moth larvae are sometimes found on live sheep, eating the animal's matted hair. But here they are dining on dead wool, made by man into a piece of cloth. The larvae build tunnels in which they live during this immature stage of life. The tunnels are made of wool and digested food. Eventually, this wool will be all tunnels and no cloth. Animal fleas are often present in rugs as well as on animals. Adult fleas spend most of their lives on and annoying a warm-blooded animal. They are parasites, living on the blood of the host animal. But the adult fleas drop their eggs off the host, and so a more interesting story is often found here. The eggs hatch into tiny, maggot-like larvae. In this stage of life, fleas are scavengers, for they feed on dead hair and other animal tissue found in the rug. Also present in the rug are the dormant flea pupae. After this stage, the adult fleas emerge. When the opportunity presents itself, they crawl or jump onto the host animal, who will provide them with blood for food to complete this cycle of life. The praying mantid is an insect eater. It will eat almost any insect, providing it's alive and not too large. Watch closely as the mantid captures its prey. Because of its predaceous feeding habits, the praying mantid is considered a beneficial insect. Although it sometimes eats useful insects, such as bees, it just as often dines on harmful ones, such as houseflies. Notice the mantid's front legs. They're of no use at all in walking, but are highly developed for another purpose, the job of procuring food. Some insects lead a fantastic life. This one, in its larval stage, is called an antlion. Notice the powerful jaws. Seen microscopically, the jaws reveal hollow tubes running their entire length. They are used to drain the life juices out of a victim. The antlion spends its time in the ground, at the bottom of a pit. The pit is constructed by flipping out sand until the walls are steep-pitched. So highly engineered is the finished job that no small insect can crawl up the sides once it has fallen in. The antlion waits at the bottom of its pit, its jaws outstretched. An ant is often the victim. Once the jaws close, the prey is helpless. the victim of one of the most specialized and ingenious insect feeders. The way insects obtain their food is a never-ending story, for insects are most adaptable little animals. New species are discovered each year. New ways of obtaining food are gradually developed, and this is often of great importance to man, because every plant and every animal in the entire world provides food for some kind of insect.
All right.
Yeah, there was a lot about that film. I mean, first, I just want to say that some of the footage of that film is actually being used in the performance tonight, because I often incorporate old school films or films from AV Geeks Archive. And
Yes.
so if you like moths, come join us again at 6
o'clock Eastern Standard Time.
Yeah.
And there were some questions, and one of them bubbled up because Jeremy paid $2 re-asking a question that Thelonious M. Unk asked, which was about the powder.
Yeah.
Moths.
Why do they have powder on their wings?
Right.
Well, so that's actually a really cool question because to start with, Lepidoptera, butterflies and moths, have scales on them. We call them scales on their wings, which is what, when you rub their wings, is that powdery stuff. And the scales are modified setae, which are hairs. So the powder is actually some modification of the hardened cuticle of insects. Insects don't have an internal skeleton, they have an external skeleton. And there's invaginations and processes that are created from this.
They don't have vaginas.
Right.
It's basically
but
pressed
they
in.
also kind of have vaginas.
Oh,
too,
okay. Well,
right?
there you
They
go. I
do
stand corrected.
reproduce. So lots of insects have hairs, and these hairs have all kinds of functions. Just like people, we have hair on our head that protects our skull, maybe. We have hair on our hands that are sensitive, so they tell us if someone's touching us or something. But so insects have similar. They have protective hairs. They have hairs for proprioception, which are body position hairs. They also have hairs that are sensory for chemical and other things. And so back to the question. So the scales are modified cuticle, modified hairs, and they're for protection. So they make the moth kind of slick, but they provide the coloration.
Oh.
So the moth itself, is not colored, but the scales itself are. And so if you rub a moth, you'll see that the wing starts becoming translucent after you rub the scales off. And there's some really cool moths that are the clear wing moths that don't have those scales, and their wings are completely clear.
Oh,
so
interesting. And some of that coloration is also allows them to camouflage, and also they fake being bigger animals.
Yeah. So that's right. So it does the coloration serves all kinds of purposes. They can hide with it. They can say that they're poisonous, like monarch butterflies have that black and orange pattern, which means, hey, don't eat me because I am toxic, it tastes bad. And then some of them have big eye spots that make them look like, I don't know, flying monsters to birds until they learn better.
And somebody else asked about aphids and... Was it aphids or just insects in general?
No, insects and CO2. I think that's a really great question. That's a really cool question.
I'm going to see if there's any more questions popping up, but you answer.
Yeah, this is the time to ask. If you ever have a question to ask an entomologist, I'll be happy to answer it now. Don't email them to me later. So anyway, but CO2. So yes, anything that respires, breathes oxygen, produces CO2, and insects are very much like humans or mammals or cats or anything else. In many ways, they consume things and they poop out waste, and they have like a system for breathing, and they have a reproductive system and muscles for moving, and sensory glands and endocrine systems and all of this stuff. And so yes, they produce CO2. But with methane, so methane is really produced in large amounts in cows and other organisms that bring in lots of plant matter, and they put it and digest it for a really long time, vomit it back up, chew it some more, digest it for a long time. And so the process of methane is really sort of more produced in these sort of long digestive processes. And so yeah, insects produce CO2, they produce methane, but they're not, any individual insect doesn't produce nearly as much as one cow, but that product of scale, perhaps.
Yeah. All right. So, man, there's a bunch of questions here. All right. So the next one is it true that bed bugs can stay in stasis permanently until a food source appears? And then if that's the case, how do they know it's a food source?
That's an awesome question. So not permanent stasis. So a lot of insects have this ability. So if you think about being a tiny little insect, food can be scarce at certain times of year. Or in the bedbug's case, the food could walk away. But also, here in North Carolina, it's seasonal. So you have like times of year that it's warm and sunny and there's lots of flowers. And then you have other times of year where it's cold and snow and there's not a whole lot of food. And so insects have all of these great ways of dealing with times of where there's less food resources. And so with bed bugs, the way that they can just like hunker down and use whatever food resources they already have, so fat bodies or a blood meal that's already been consumed or whatever it is, and they can hang out for a long time without eating. I don't know the exact number of days, but I wouldn't be surprised if months go by and the bed bugs are still fine. But they will die eventually without food. But more than that, insects desiccate really easily.
Desiccate, dry out.
They dry out, right? Yeah. So lack of humidity can be, or if that exoskeleton gets cut in any way or hurt in any way, they can dry out really quick. So no, they can't last forever without food, but they can wait. They can probably wait you out.
And so that's the whole desiccation thing is I'd heard that some people would heat up a room to try to deal with bed bugs.
Yeah, so there's lots of different things that people have tried, diatomaceous earth or other things that includes like cutting the cuticle. I would actually just call an expert really to.
Got it.
Sorry, but the good thing about bed bugs is. They take a little bit of a blood meal, they're itchy, but they're not like mosquitoes or lice or some of these others that carry some really major human diseases. So they have kind of a stigma. People get real upset about them, but they're actually, they're all right. So, yeah, Wow. If you have bed bugs, don't worry about it too much. Just get them taken care of. I've been fed on bed bugs before. I've been a food source for bed bugs.
Like on purpose or like after the fact you realized?
During travel. Yeah, during travel. They got me between the big toes, which is like, ugh.
Oh, that's annoying.
Yeah.
So Jim Palmer asks, are there any insect meat eaters?
Insect meat as in the sense of they eat vertebrates? Yes. Okay, I'm just going to assume that that's what he means.
All
right. Eats large, like cows, insects that eat cows or sheep or something. Oh, yeah, most definitely. There's tons of different kinds of insects that really like meat, especially after the animal is dead. So, roadkill on the side of the road, it's dead meat, but there's, first the flies come and lay a whole bunch of larvae and start the decomposition process, and then after that the beetles come and they eat more. So they're doing us a really big service by eating meat. But there's other examples of meat eating insects. There's different flies. Back in the western United States, in cattle ranches, there used to be a big problem with a kind of fly called a screwworm. Where they would the adult fly lays their eggs on, if a cow or something has a cut, it lays its eggs nearby. And this screwworm, the larvae eat living flesh. So not cool. Not
Yeah.
cool.
Yeah, that's horrible.
Yeah.
Ugh.
So they, entomologists, there's a big field of entomology that have to do with livestock management and agricultural management that's really important. And so they worked very hard to help eradicate screwworms from Western United States. But yes, they eat meat. There's even a bee. So bees are mostly herbivores. That's just why we like bees.
Right.
Right. We don't like wasps because wasps eat meat.
Right.
And bees eat pollen, which is, just a plant. But anyway, there's a kind of bee that also enjoys occasionally scraping a little bit of flesh from a dead piece of roadkill.
Oh, wow.
So
Okay.
it's
What does that honey taste like?
Evolution comes out. Well, not all bees produce honey.
Oh, that's right. I forgot.
Yeah. Most of them don't. I mean, they produce like little tiny, capsules of pollen and, some vomited up stuff and some honey together for their young, and that's what their young eat, is these capsules of pollen and regurgitated bee love. Which we call honey.
Yeah, regurgitated bee love. That's a great name for something.
I don't know. Are there any other
organic,
questions? This is really great.
Yeah. Let's see. Let's take one more question.
Yes, centipedes are arthropods. They're in Chiliopoda, which is evolutionarily close to the Diplopoda, which are the millipedes.
I should say, if you like what you saw, join us tonight. Tonight is not going to be a question and answer. This is a performance about moths and about the Irwin Moon and the Moody Institute of Science. So that's 6 o'clock tonight on YouTube and other places that I normally show stuff. If you like what you saw, hit the thumbs up button, the like button. You can buy some coffee at ko-fi.com or patreon.com/avgeeks for both of those, or the super thanks. Jeremy, thank you for that. And thanks, guys. Let's see, any more questions before we say goodbye temporarily to the guest lady, Katya?
Yep. Any more questions? Anyway, I love all the questions about insects. That's really wonderful. North Carolina State University, for those who are in town, have a really great entomology department. One of the best.
Yeah, and I'm going to be
world.
doing a show at DHL Library towards the end of February with a local urban entomologist who had the same request. She's like, I want to see things about pollinators, but not honeybees.
Yeah, well, we do want this. Like, we want films. And actually, I was really impressed with the number of unusual insects that were in these old school films, because we think that they're going to all be honeybees, praying mantises, and cockroaches, right? Flies, which are the insects that a lot of people know about. But they had great other insects, too, which is great.
Nice. Let me see any more questions? This is the funny thing about
vampire moths are amazing. Yeah, so if you should really come tonight, because there's a little section about the things that moths and butterflies eat that are a little bit uncommon. But I won't tell you now because I'm not doing the show now. Right. What else?
Is it true wasps make dates? I don't know if he's...
Fig wasps. I think that's so, not dates, but figs. Yes. So agriculture can be a little complicated. So there are kinds of edible figs that don't actually require pollination to produce fruit and stuff. But yes, there is a fig wasp, which is a ficus. The genus of fig are pollinated internally. So it's like a flower. The fig is actually an internal flower structure. And the wasp, female and male, crawl around inside of that, and they lay their eggs inside of the fig. And while doing this, and mate inside there, they make it a home. While doing this, they pollinate the fig plant.
Nice.
Yeah.
Well, thanks everybody for tuning in today, and hopefully we'll see you tonight at 6 o'clock Eastern Standard Time.
Oh. Whenever.
Yeah.
Thanks, everybody.
Goodbye, everybody. Everybody have a great weekend if I don't see you, and we'll be back next week with even more films to watch.
Thank you again, Katya, for coming by, hanging out.
Yeah, thanks, Skip.
Yeah, and we'll see you soon.
Bye.
Bye, everybody.